Hi, welcome to video demonstration of multi-class classifier SDCA maximum entropy algorithm. So let's begin. In this part of the project, you can see the multi-class classifier SDCA maximum entropy solution. Within that, we have the dependencies. So let's make sure that we have the updated Microsoft.ml package. So let's go to manage NuGet package and download the latest package from nuget.org. So we are going to select Microsoft ML and we are going to update the package. Click OK here, and to make sure that the package has been updated. Yes, it has. So we are done updating the package. So we are using the same iris data.csv file as far as our training data set for training the machine learning model. And we have the same iris input data model.cs class and iris output data model.cs class. And you have seen this class in previous chapters. So we have the Microsoft ML.data and the 5 properties of iris input data model. We have sepal length, sepal width, petal length, petal width, and label. And in the iris output data model class, we have only one property, public string, predicted labels. I'm not going to spend any too much time on this, as you have seen this before. So let's look at the program.cs file. And here we are using the system library, system.io. And then the usual Microsoft.ml, ml.data, ml.trainers, and ml.transforms libraries. And then we have using static Microsoft ML.data operations catalog library as well. So next we look at inside the class program. The first step is we declare the path to save the trained machine learning model, static read-only string model path, and path.combine environment current directory model.zip. Within the main method, step 2, we instantiate ML context, new ML context. Step 3, we instantiate training data view, and we use ML context data load from text file, iris input data model, path iris data.csv, has header false, separator character, comma. You have seen these statements before. In step 4, we declare string features column name features, and for data preparation pipeline object, we use ML context transforms.conversion map value to key label, and append method and pass ML context transforms.concatenate. We concatenate the 4 feature columns, sepal length, sepal width, petal length, petal width, as we have discussed in previous chapters. And we use the append cache checkpoint and pass the ML context. Step 5, we create the SDCA maximum entropy multi-class trainer. We use data preparation pipeline.append method. We pass ML context.multi-class classification.trainers.sdca maximum entropy. And we pass label column label and feature column name features column name. And step 6, we split the training data set into 80% for training and 20% for evaluation. Train test data ML context data dot train test split, and we use test fraction 0.2. You can vary the test fraction to run your experiments to see how it affects the overall performance of the machine learning model. Then in step 7, we use SDCA maximum entropy multi-class trainer.fit method and pass train test data.trainset. Step 8, we create the matrix to assess the performance of the machine learning model. We use ML context.multi-class classification.evaluate and pass model.transform train test data.testset. Step 9, we write some console.writeLine statement to get the output of the matrix and assessment to the console. We have confusion matrix, macro accuracy, log loss reduction, top K accuracy, and top K prediction count. Then in step 10, we create a new iris flower and we specify prediction data and specify sepal length, sepal width, petal length, petal width features. Step 11, we declare predictor and using ML context.model.create prediction engine. We pass the input data model iris input data model and the output data model iris output data model and pass the train model as part of the method argument. And step 12, we create the predicted class of flower, and we use predictor defined here in step 11 dot predict and pass prediction data, similar to the previous chapters. And then we have the statement to pass the prediction to the console. And step 14, we use the file stream object to save the trained machine learning model to the specified path. So here we have the multi-class classifier SDCA maximum entropy algorithm. So let's run the program and see the output. So here is the output, and we can see multi-class classification algorithm SDCA maximum entropy, and the confusion matrix table is given here, and we have 3 classes of iris flowers. As you can see, the macro accuracy is about 94% and micro accuracy is 95%. So this model is performing really well compared to the naive Bayes algorithm. So you can see that again, the purpose of writing this book was to show different classes of algorithms that has been that are part of the Microsoft.ml package. And using different algorithms on the same data set, we can see the variation of their performance to give you an idea as to how these variations may affect the training of the machine learning model and therefore their use in practice. And we hope that you enjoyed this presentation. Thanks so much.